Newton's laws, and in order to do that properly, we're going to need to talk about forces, and forces do not always neatly line up in an x direction or a y direction. So down here below, I've got this force that I've drawn in between my axes. I've got my y-axis going up and my x-axis going down, and this force is between the two. So it's not in the x direction or the y direction, it's actually in both. Now, in order to figure out what's going on here, I am going to take a light bulb right here. I'm going to make myself a light bulb. Oop, here's my light bulb. And it's going to throw some light downward here. And then that is going to cause my force to have a shadow on the x-axis. Oops. Okay, and my shadow is going to look like that. And so I'm going to call this my force in the x direction. Okay, so here's my force, but the shadow of that force on the x-axis is my force in the x direction, or my x component of the force. So you might see this word, component, which means a part. Okay, so the part of the force that is in the x direction. I can turn that around, and I can also put a light bulb over here. Here's my light bulb again, la, 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 and it's throwing out some light this direction. And I'll get a shadow of that force on the y-axis, which looks like this time. How come the shadows are not the same? Well, it's because the force is not oriented at exactly a 45-degree angle. If I was at an exact 45-degree angle, then the y component, or the shadow on the y-axis, would be the same as the shadow on the x-axis. But here, my angle down here is lower than 45, so my x shadow is longer. All right, so like if we redrew this thing, like let's say I drew my force, I should change colors again. If I drew my force way down here, then I would still have the same length of f of x, my x component, but my y component would be much, much shorter. It would be cut off there. Or if I put my force right along the x-axis, like so, then I would still have the same x part, right? My force and the x component would be the same, but my y component would drop off to 0. There's no longer a force in the y direction if my force is completely in the x. Okay, so what? What do we do with this? Well, we need to figure out the relationship between the total and the two pieces. And I say two pieces because we could have a force in the z direction, but not in AP Physics. We're just going to stick to two direct dimensions. That's enough to handle at this point. If you continue on with your career in physics, you may see forces in 3 directions. If you are Googling stuff, you'll also see this, that sometimes they don't call it the f of x. They will say that this thing is f times the I vector, and over here it would be f times the j vector. It's just another notation for the same thing. Basically, they're saying project this force onto the I-axis. And in physics, the I-axis is your x-axis. And over here, they're saying take the force and project it onto the y-axis or the j-axis. It's just another way of just saying, like, how are these things like written? I prefer the x and the y subscripts, and that's pretty much how AP does it as well. Okay, so let me draw out another force here. Let's say here's our force, and I am going to say that this thing is a 5 Newton force. Okay, If that's a 5 Newton force, then I can break it into its pieces along the x-axis and the y-axis. Now, where are the x-axis and y-axis? This is a reference frame thing. You can choose whatever reference frame you want. Okay, so I could say, well, look, I'm going to choose a nice, easy reference frame for me. Here's my x-axis, and then here's my y-axis. And look at that. My 5 newtons just happen to line up along the x-axis. But sometimes it's not going to help you. Like in this particular one, I said, well, like, tell me what the 5 newtons are for the x and the y-axis. That's easy. It's 5 newtons along the x-axis, and it's 0 newtons along the y-axis. But that's kind of cheesy, and it won't always work. So let's put up some pretty standard axes here. I'm going to call this my y-axis, and let's make this my x-axis, like so. So now I need to figure out how to break this 5 newtons into an x part and a y part. So let's make myself a triangle. I am going to find out, oops, nope, get over here. Okay, you're going to be a pain, I see. Let's do it this way. Okay. Now, let's see if I can drag it. Yay, I can. Okay, so now I have the x part of my 5 newtons. And now I have to get my y part of my 5 newtons. So let's see here. If I start down here and go upward. Okay. Let's move that one into place. That's pretty close. No haters. That's pretty close. All right, so this I'm going to say is my force in the x direction, and this is my force in the y direction. I know an angle here. I know that this is 90 degrees. How do I know that? Because the angle between the x-axis and the y-axis is 90 degrees. If I drew it properly, that's 90 degrees there, which means this thing is 90 degrees here. Is there a way to figure out what my components are then? And the answer is not really. You've got some techniques. You could say that f of x squared plus f of y squared is equal to 5 squared. Where did I pull that out of? That, my friends, is Pythagorean Theorem. So go Pythagoras. Ooh, yay. Okay, so but I don't know f of x or f of y, so that's a problem. We could also assign an angle in here. So I'm going to call this theta. We could call it anything, but usually in physics class, angles are named theta, which is just a circle with a line through it. And now you have some trig identities which are going to help you. So we need to start identifying some triangle pieces. This is going to be our opposite side because it is opposite the angle. This is going to be our adjacent side because it is adjacent or next to the angle. And this thing is our hypotenuse. So let's change colors here. My 5 newtons is my hypotenuse. My f of y is my opposite side. And my f of x is my adjacent side. So some of you who've had trig before know that the sine of that angle is equal to the opposite side, which is f of y in this case, over my hypotenuse, which is 5. So it's opposite over hypotenuse. Now, should you memorize that the sine of the angle is the y component over the hypotenuse? No, you should not. Because if I drew the angle up here instead, if I made theta up here, now my opposite side would be on the x-axis. So you need to know the actual trig identity that sine is opposite over hypotenuse, but in this case, it's f of y over 5. Now, What if I wanted to find f of x? Then I would need the function cosine, because the cosine would be f of x over my hypotenuse, which is 5. Or the actual identity is adjacent over hypotenuse. And that would allow me, if I knew my angle, to also find my x component. And then last but not least, tangent. Now, if I have tangent of theta, that is, oops, my pen is laggy here. Hold on a second. That's going to be my opposite side over my adjacent side. So let's see if my pen will behave. It is not. And so in this case, while I wait for my pen to recover, it will be the f of y over the f of x. Okay, machine, come on. Here we go, pink, pink. So it would be f of y over f of x, or the actual identity would be the opposite side over the adjacent side. If you don't know your trig identities, if you don't know that cosine is adjacent over hypotenuse and that tangent is opposite over adjacent, you should really, really, really learn them. You're going to need them almost every day from here on out. If you don't know Pythagorean Theorem, that a squared plus b squared equals the hypotenuse squared, you need to know that. That is a super important thing to have under your belt, because we're going to use it all the time. So you notice we didn't actually solve anything because I didn't really give you any numbers. So if we went back and I said, well, look, let's stick in some numbers here. Let's see if I can erase some stuff without getting too crazy. Okay. Here we go. I think we're back in action. Okay. So let's say that this one right here was 3 newtons. So I've told you that the force overall, the total force, or the resultant force, is 5 newtons. And I've told you that the y component of that 5 newtons is 3 newtons. How do we find my x component? How do we find f of x? The easiest thing to do is to use Pythagorean Theorem. I know that 5 squared is equal to my 2 sides squared. So 3 squared plus f of x squared. Or 25 equals 9 plus f of x squared, which if I bring my 9 to the other side, that's 16 equals f of x squared, or f of x equals 4, which you may have noticed right away. You say, well, Sterman, like, isn't this just a 3, 4, 5 triangle? Which it is. Okay. What if I asked you what this angle was down here? Well, now you know all your sides, so it doesn't matter. But let's go back to our original conditions here. We knew our 5 and we knew our 3. So we know the opposite side and we know our hypotenuse. So we need a trig function that has both opposite and hypotenuse. So this one's dead, it's got adjacent. This one's got adjacent. So I need to use my sine. So the sine of the angle is equal to the opposite side over the hypotenuse. Or the sine of the angle is equal to 0.6. Now, to get the sine to the other side, I'm going to divide both sides by sine. So in a math class, instead of doing 1 over sine, usually they do it this way, sine -1, which is the same thing as 1 over sine. And now you're going to take your calculator and figure out if sine of theta, if theta is equal to the arc sine of 0.6, you're just going to plug that in your handy dandy machine here and say 0.6 arc sine, and I'm going to get 36.8 degrees, which I'm going to round and say 37 degrees. Okay, so that's an introduction. We're going to do this a lot. If you know you have weakness with trig identities, then you're going to want to definitely do a lot of practice with me over the next couple of days. Good luck.